Hi everyone. Today I'm going to explain the code of our project, Kaggle Agentic AI project. So let's see. First of all, we have installed here Streamlit. Why? Because we are deploying the project which we have made on Streamlit. So this is the reason we have here installed Streamlit over here. Then we have installed pip and upgraded it. Here there are some Python libraries over here. And next we have seen again, these are some Python libraries only, scikit-learn, pandas, numpy, matplotlib, cpon, catboost, and etc. And we have
Next, if we
imported
see
here some Python libraries like pandas, numpy, scikit-learn, and catboost. Also, we are using over here, and we are using catboost classifier also, and we are training and testing the model and splitting it. As we have seen in the CSV part, we have taken World Risk Index. This is our that we have used the data set of World Risk Index over here, and we are shaping it, and we are getting column and data types of it. Okay, so let's see here. Here we have got region, world risk index, exposure, vulnerability, susceptibility, lack of coping capabilities. These are some values which we get in world risk index. So these see here, this according to regions, we have their values over here. Okay. So let's go move further. See, this is the columns which we are using, and we have the region according to this is the data set over here. And yeah, let's move further. So here we have the targeted value region. Again, this is all same thing. Again, if we go down, we are cleaning the data. First of all, we have taken the data set and we are cleaning and testing over here. So yeah, see here. After cleaning the shape, we have got here 1916, comma 9 and 1916 dot comma. This is something we have got over here. And next, we have got the selected data set. We have writing and fill we are using over here for safe imputation. And see the cat booster is used over here. And we have got the final feature matrix shape. We are getting the final output in matrix shape that is 1916, comma 80. Okay. Yeah. Let's move further. So as we are using cat boost classifier also here. So see, this is the iteration of 600, learning rate of 0.05, depth 6, even matrices accuracy, where boost 100, random seed is 42. And we are training the classifier. So after the training, what we have get is, see, this is the output which we are getting after the training. So this is the score, like a cat boost score, and remaining is 40.9 seconds. This is like time set which we are getting over here. So let's move further. And let's see the accuracy, which is the important part, how much accuracy we are getting in our data set. So let's see over here. This is the accuracy of 94.27%. Pretty good. And see here, what we are getting is classify report. Let's check the F1 score and support over here. So see the high, low, medium, very high, very low accuracy, macro, weight average. So these are like positions in weight average. Last 0.94, recall is 0.94, F1 score is 0.94, and the support is 380. So next we are seeing here, we have done the crosshair of the following, and we have done training, testing, and splitting over here. So let's see, the core is over here like this. We have trained the final regressor, and then we have got the output. See, the output is, we can see here the RMC score of 0.647801 and R2 score of 0.982832. Yeah. So here the final model has been trained over here, and we have got the graph. Let's see the graph. Exposure. We have the following things in our graphs are exposure, vulnerability, lack of copying capabilities, susceptibility, lack of adaptive capacities. See, this is the importance, this side, and the top 10 features in the cat boost. Yeah. So again, after this graph, you can see here the exposure is so high. According to it, we get the predictions like there is a low risk or high risk. So let's see further more about it. And the model is saved in artifacts, WRI regression joblib. So as we have imported joblib before for this reason only. Yeah. So if we move further, we can see this is this directory we have just saved over here. We can just ignore it. And if you move further over here, we have used again, we have taken one model and we have trained it, tested it, and we cat boost and random forest, and like we have used here three models. Let's show me the output. Yeah, see, in this model, we have trained on cat boost, random forest, and voting assemble, so that we can see which is like more good further. So we have seen here, and the final performance report, we have got extra T's, cat boost, voting assemble, random forest. So let's see the model performance. Yeah. According here, we are seeing which is better is over here. Random forest is getting prediction. Yeah, we see this is the graph prediction we have, and the actual prediction in the plotted graph. See, perfect prediction. It's going on above side. And most risk factors. This is again the 61.4 percentile exposure, popping capabilities, susceptibility 7.3, and vulnerability 6.1. Yeah, this is the thing. And the project completed perfectly on your system and it's ready to deploy, I guess. So let's check the R2 score minus 107.335. Yeah. As I will just say you one fact about it, as we get the value in negative, more negative we have this, it's like it's trained very nicely. Yeah, let's move further. And we have again trained tested over here the models again, splitting all is done. And here let's see the comparison which was going on between extra random forest, voting assemble, and light GBM. So we have got the result is our champion is ready. Voting assemble won the competition over here, which was we are running on 3 of week before we have seen. Yeah, see, we have got more result than before. Before we have got something negative 100 something, and now we have got minus 260.2305. So here, like according to voting assemble, we have this model is like perfectly trained and it's like so good. So let's see the output and graph once. See the champion wins. This is some output. Champion ready. These are like we have got output over here. And the global risk drivers, the graph. Yeah. Now let's check the final comparison report about it. Yeah. So the model performed leaderboard. As we know that voting symbol one. So this is the voting assemble, then light GPM, random forest, then expertise. There's the key results over here. 0.31 very low error. This is some like R2 score, some values key results over here. Look into it. Yeah, some sample predictions over here. According to the data, this is some region names and one risk index predicted the error by generated over here. Yeah. So here, this is the stacking model. Now let's see in the stacking model, we have imported some Python libraries again. And let's see for this is our data set, world risk index, as we see before. Again, this is the region here, this is the columns over here. And for the best powerful training and cleaning models, we have used X-Train and Y-Train over here and creating final stacking model. So this is the code, and we have got the final artist score 0.99578 and RMC for 0.3489. And model is been saved, winning model 2025.pkl. We are saving here the model in .pkl file, which has been compressed and it's less than. So guys, now I have opened the command prompt. Now let's see the deployment, how it's coming the outputs. I have entered some like in come up with some codes, and like after entering the run.app.py, now it's like local host we have get the output. Let's see, this is the final output of our project. So as we have seen, exposure, sustainability, lack of adaptive capacities, vulnerability, lack of copying capabilities. Now like if for example I have set here this, I have got the medium risk over here. Again, if the exposure, this is a very low risk, and this is the very high risk. So this is the final output which we are getting. So guys, we have came on the Streamlit platform and we have deployed over here. Now let's see the deployed link over here. The deployed link. See, this is the deployed link, Kaggle Gmail project, and this is the deployed link. And we have seen our project over here as exposure. Let's see it's working or not. Yeah, exactly. It's working properly. So at last, this is the final deployed link which we have seen in this, and we have given in the link also of Kaggle submission there. If you can get the link and you can just see the results what we have get and see we are getting this very low risk, high risk, and this is all case. Okay, thank you so much. Bye.